Good day, good afternoon, good morning, wherever you are. Welcome to my talk about running trusted payloads with Nomad and Waypoint. Let's first introduce myself a little bit. As I said, I'm Bram Vogelaar, and I actually went to university to become a molecular biologist. That seems far away from operations and engineering, but it was a quite gradual slide down to the dark path, as my colleagues used to say. From a biologist, I went to bioinformatician or developer, getting through the 500,000 data points a week that we were generating. And in an academic world, the developer is also the server guy, so that's how I picked up config management and operation skills. Now, for the last decade or so, I've been in operations, and I'm currently a DevOps cloud engineer at a Dutch consultancy company called The Factory. So, to start off with my talk, I would like you to ponder the statement that's currently on the screen. So, imagine the situation, it's Monday morning, it's stand-up time, and the intern just proudly announced that he solved the problem we've been having with our main product, our moneymaker, by fixing the database connection. And I'm probably right when your reaction right now is similar to the person on the screen. It was also my reaction on the screen. So, as a background, this is pretty much a story of my youthful history as an operations guy. So this actually happened, wasn't the database connection we were discussing, but yeah, a fairly junior person quite proudly announced that he fixed something in our main product that to most of the people in the room didn't seem related to the problem we were facing. So first of all, everybody's gut feeling was, why did you deploy on your own? Why did you deploy on Fridays? We don't do that here. But instead of scolding my young colleague, me and the other people in the room actually started thinking, why don't we deploy on Fridays? Like, why was there nothing in place that would have... So the product was still fine, we're still making money. So what would we need to have in place to make sure that the code that our intern pushed out of the goodness of his heart, like, what do we need in place to make sure that doesn't cause any problems? Or in a worst case scenario, even a bad actor inside or outside our company, if they were to be able to push code to us, how do we prevent bad code or, mistakenly bad code, let's say that way, into production? And of course, when we looked at this code, the case for him didn't make it any better. I'm not showing the actual code. This is actually code. This is valid code. It's functional code. It's code that creates Mandelbrots. And Mandelbrot is a type of image, and this code is shaped like a Mandelbrot. So it's a Mandelbrot shaped code creating Mandelbrots. It's actually a winner of a competition to create the most obscure code, and they seem to be winning, at least in my case. But the code the intern produced wasn't as obscure as this, of course, but it was hard to read, it was hard to follow. We weren't exactly sure that it actually had any effect, or if it had a good effect. So that didn't help, right? So we had to have a conversation about, so first thing we did is lock everything down. And that's not necessarily a bad thing, but it of course, he made the mistake of shutting it down too much, so it became an impediment and people started to try getting around it. So closing down on yourself is not always the right option. It's making sure that people can do their job in the most secure way possible. So, because, right, we're in the business of, selling stuff or servicing people, but in the end, we need to get our product in front of people. And to do that, we need to have confidence or trust in production. So we need to make sure that everything that we do or put in between a developer station and production or a customer is to the benefit of giving us the confidence that it will work. So I borrowed here a definition of chaos engineering, which is an advanced feature of this all, of testing. So getting confidence in production. And so we need to open it up, but we need to have a process in place that will provide us confidence so that we can allow people to push code. Or we don't push code for the sake of pushing code. No, we push code for the sake of providing new features. So we should be able to release new features and not praise. So first step to gain trust, of course, is adding tests, both unit tests, so small tests that will make sure that the code will run, operates in a way that we think it does. Then we'll add a layer of integration test, basically exposing it to the wild world for the first time and making sure that assumptions it makes about how the world looks like actually are in place. And then, of course, system integration test and end-to-end is actually a surpassing phase of the same concept. We'll open up our system to more outside places that have different contracts or different promises, and how our code acts with those contracts or promises. From, if you're a fan of promise theory, right? Because a system can say that it's supposed to do something, like I'll be cleaning my room, but our code will need to validate that the room is actually clean, right? If you ask my 16-year-old self, did you clean your room? The answer, of course, is yes. But the truth might be a bit far away from my answer. And so your code and your test not only need to test the happy path, it needs to also make sure that it tests the failure path or the dark side or whatever you want to call it. So adding testing, just to make sure that our developer, our intern, doesn't produce unlegible code again, we introduced code reviews or a 2-man 4 eyes principle. Right? So we always made sure that before code can go to production, at some point during the process, someone else has looked at it. Not only for code quality purposes, but also nefarious reasons. Not that we suspect anybody from being an actor, bad actor, but there's a possibility, especially when you're in more advanced or high capital places like banks, for instance. So put it in place, but make sure that it's helpful, in a way that it creates trust, it creates better developers, but make sure that the process is not blocking in any way. So make sure that you'll have enough people to review your code, that it happens quickly enough. Most of the time, your CICD system can also help you out. Talking about CICD and making it simpler, I'm used to a lot of CICD tools, Jenkins, GitLab runners, the Travis CI, GitLab Actions. Most of the time, you'll be allowed to write freeform pipelines. That's good, because I can do basically anything I want. But also, going from project to project, it makes it difficult. So everybody writes their pipelines in a slightly different way. Naming things is hard, so steps will inevitably be called different in every pipeline, although they do the same thing. And this is where HashiCorp's Waypoint comes in, and it's a fairly new product they released. And it's an excellent tool that could help us formalize way we deploy things. And that's because it has a built-in step naming convention. Waypoint, the pipelines are written in the HashiCorp configuration language. People that are used to the HashiCorp product suite are should be fairly familiar with it. Packer uses it, Terraform uses it. So not only now you have a shared DSL, a domain-specific language across all your product. So not only the configuration management people or your ops, traditional ops people will write using the same code, but in Terraform, but also the developers that are creating their own pipelines will now use HTL. It's easily extendable, but by having a plugin framework, so if anything is missing, you can quite easily add it yourself. Or hopefully someone in the community will have had the same problem you have currently and will have written a plugin already. So what does it look like? What I mentioned already, it has a set nomenclature for pipeline setups. So here was an example product for a project called Lorem Ipsum, and it will have 3 standard steps. It will have a build step, it will have a deploy step, and it will have a separate release step, which is nice, which is you don't see in too many CICD tools. Immediately, so you have to shoehorn it in, but in Waypoint it's already built in. So you can deploy something, but you don't expose it to your user set, which is a very powerful tool you have in your toolbox to be able to make sure that everything is ready and then you deploy it to customers instead of having to show them a sorry, we're down for maintenance screen for a while. So of course your CICD, there's a lot of places that you'll have need for secrets or passwords, and a lot of tools, the first initial way to do it is hard coding it into code, and basically means there's now a plain text password somewhere in a config file that basically the entire company has access to. So you can, of course, as we did initially, you can restrict it, but there's another tool that HashiCorp provides, which is Vault, which is their secrets management tool, and it's open source. It can help you with your tokens. It can save passwords. You can retrieve passwords. It can help you do certificate management, and it even can help you. And that's why I'm focusing on right now is what I call password as a service. So Vault has the ability to create short-term SSH passwords or MySQL passwords, and there's several others. But that way, you no longer need to hard code a password somewhere. Now you have just a step in your process that says, I need to deploy something to a new server for which I need SSH. Please generate me a SSH key that's valid for the next 10 minutes. It auto expires, so there's no interactions, there's no lingering passwords that in the system that happen to be on everybody's post-its on the screen, because that's your get out of jail card now. Vault now creates the password, you use it for 10 minutes and it automatically gets removed, which is brilliant. This is where we are in the process of internal. So what I call internal, this is the internal process where one writes code, where we build it, we check it, we deploy it to customers. But there's other ways of people, bad actors, so can involve the system. So from now on, what I'll be discussing is how can we prevent bad actors from interacting with our system or manipulating us in doing something or deploying something that we didn't want to. So before was unintentional mistakes. From here on in, we'll be discussing intentional bad actors. So first of all is an advice I got from one of the CTOs I worked for: do not trust the internet. His version includes profanity, but for the sake of this presentation I won't. So I'll stick with do not trust the internet. And that's annoying because we want to stand on the shoulder of giants, which has pros and cons. And we'll be discussing a few of those in the next slide. Right? When we write code in either our Node, our PHP, our Ruby, great people have gone before us and they've written very good packages. So we want to use npm install, we want to use composer install, so that we spend our time writing the code that we need or that we make money with, and everything else will pull in as a dependency for the boring stuff that nobody's interested in writing yet another object mapper for any databases, right? Use the ones that are used, use the ones that people are frequently using, so the bugs will be out, more people have looked at the code. But that brings us in trouble, because as we discussed in the previous slides, let me introduce the concept right now. So the concept of supply chain attacks. So people attacking the bits outside your own infrastructure to make and which you have no control over, right? The npm.org is not under your control. So if people manage to remove packages that from npm, you're in trouble, right? You have continuity problems because happened before a developer got mad for some reason and he pulled all his packages, which happened. A lot of other packages happen to depend on, and which other packages happen to depend on. So basically, half of the internet couldn't deploy on a Friday. Not only didn't want to, but literally couldn't. So you have a continuity problem. And that's actually, in this scenario, is the best scenario to have, because you can't deploy. But what if someone managed to hack into someone's npm account or RubyGems account or their Maven account and managed to inject bad code? Crypto miners come to mind if they're not actually interested in ruining your product, but just your reputation by using everybody's computer to mine code on. You can say that's far-fetched, but it isn't. If you Google supply chain attack, then your favorite programming language, you'll find that even in the last year, pretty much all of the languages that have a central package repository have been either attacked or successfully attacked. So we should have a way of not trusting the internet, which basically means pull everything inside. So have your own operating system repository, so run a pulp for your RPM stuff, for your Debian stuff. Pull in every base image you're interested in, run it in your own image repositories. Pull in, as I said, make a own cache of npm packages, Ruby packages. Use tools like Artifactory to pull everything in, so you no longer have a continuity problem. So because if the upstream provider pulls it out, you still have the local version. But it also gives you the opportunity to create what's called a software bill of materials. It's something that came out of corporate America, but it's very, very convenient to also do it. It's spelled. It will take a little bit of time, but it will teach you several things. First of all, it will actually teach you what is included in the first place. You think, from a high-level perspective, because you'll have a RubyGems file, but or whatever the equivalent is in all the other languages, but those packages have dependencies, which have dependencies, which have dependency. So especially if we look at the Node community, lots of packages are split up in very small components. So you'll end up pulling in easily a couple of hundred packages, which is harder to keep track of unless you create spend time creating a software bill of materials. So I have a list of what is included, what they include, and so on and so forth. That also gives you the opportunity to scan for unwanted licenses. For instance, if you have a commercial product that you ship, then certain open source licenses might not be what you want to use. So it makes it easy to scan for licenses. It also makes it easy to scan the packages that you have in your local repository or the images you have in your local repository for problems, vulnerabilities, and other unwanted things. If we look further in how we could do this, the two ones I want to highlight today is Claire, which is an open source tool to scan images, and SNCC, which also does images but can also scan packages. So if we look at the Waypoint pipeline, we can easily extend the build phase by a before and an after hook. And in this particular example, I'm making sure that before anything happens, I'm scanning and doing a SNCC scan on my local repo and my image, so that whatever comes in is clean, is good, it's usable. Because otherwise, when we put garbage in on the one end, it's never going to get better. It can only degrade. So from the start, we start scanning, we start doing validation. Taking it further, so when we scan it in the beginning, we're not necessarily sure that whatever ends up on the other end is the same thing. So we're not going to promote code, but we're going to promote artifacts. And what do I mean with this is, do not use, and it's easy, it's some CICD tools even promote it, but don't do a merge from acceptance into a branch called production and deploy that. That brings several problems, especially when you do the npm install on production and this angry developer has moved this package, then your continuity problem actually becomes downtime, because at that point you can no longer deploy. So and deploys take longer, so you're not you're not in control at that point. So make sure that you have a build phase, create an artifact, either an operating system, a native package like RPM, which gives you lots of opportunities to do LCM, or as more modern, you need to stick it in a Docker image and promote the Docker image through your Docker repos. So make sure that there's a process or flow in place that doesn't expose your container directly into production, but make sure that we can first use it in test and have a process in place that it either tags it different or moves it completely into different Docker registry. For that, I want to introduce Nomad. So we'll have, in my process, I decided to use Docker. Friends don't let friends use Kubernetes because it's great, it's cool when it works, it's terrible when it breaks down, and it's basically reinstalled to fix it. On the other hand, Nomad is a very cool tool to do dynamic workload scheduling. It can do batch jobs, it can do containerized jobs actually, which we'll focus on, but it can also do non-containerized applications. So if you have a Java jar project, again, an artifact, we can easily run it. It has Consul and Vault integrations, so we have basically service discovery for free, we have secret management for free, but it also has its built-in token-based access setup. So we can grant people the permission to deploy into certain places. And again, as I mentioned before, it uses, and not specifically about Nomad, but it also uses the HTL configuration language. So we have a shared language between all our tools that we'll be using. What does that look like? If we want to deploy our lorem ipsum job, we'll have something called a job, which has a group, which exposes my static port on 8080. It has a task of type Docker, and it uses my lorem ipsum image that we've created before, and it exposes it on the port that we defined. Most of us will trust our upstream providers, say Docker, say AWS registry or the Azure registry, but it has the same problems as I mentioned before. We do not trust the internet. So things can even be compromised at the big players. I'm not saying it happens, I'm not saying it will happen, but it's a risk, especially when you run it yourself. So we need to start looking at signing our packages. For RPMs, we've been doing it for 20 years or more, so there's an established workflow, but in the next couple of slides, I want to look at how we can add trust to our images by signing our images. Here I'm using a built-in, well, not a built-in, I'm using a image registry which is open source, which is part of the CNCF, which has Docker Trust built in. Unfortunately, actually Amazon does not. So if you're looking for something open source, have a look at Harbor. Trust, content trust, basically in the context of Docker means we want to sign our images. You probably want not sign with my key. So first of all, you need to create a key. We load it into Docker saying, I trust my key. And then I start building my images, start signing my images. By signing my images, and that I can actually push them to my registry. So on my end, creating the images is now fully signed. Of course, you should make a separate key for your CICD systems and keep rotating them, just like you would an SSH key. Because if this starts leaking somewhere, then you're in trouble. So you can also stick them in Vault. That's an easy way of making sure it doesn't leak. And then on the other hand, on the running side, I can actually I can inspect images, saying let's have a look. There's a new release of version 1 of my demo app, and if something has happened, for instance, I was saying where we are compromised, you can easily revoke an image, and then it will no longer be presented to any of your agents. If you want to run it, make sure that on your Nomad machine you have a system variable called docker_content_trust, and have that set to 1, and then you can start pulling in images. Of course, you have a problem when your image let me go back a slide. So when you pull in an image, you you shouldn't be trusted, you're basically too late. That's Nomad's already running, you might already have exposed it to your customers. So make sure that in your CICD, and I was hoping to show a way of doing it in Waypoint already, but I haven't managed, or directly in Nomad, which does work, but it's less convenient because now I need to make sure that all my development teams have a certain pre-deploy hook in place that basically does this Docker Trust inspect. So it needs to make sure that my image is correct, trusted, and it actually has the hash that we're thinking it's going to deploy. So make sure that you have a little bit CI process surrounding your Waypoint deploy that makes sure that it does validate your input. And that brings us to the end. So I hope that I'm not showing you that we not only can correctly cuddle our developers and helping them create good code, but we also created a ring fence of processes to protect us from bad actors coming in. That's really the end. So thank you for listening. If you want to talk more, I'm available on YouTube or wherever the comments are at the moment, or email me if you really want to rant. Tag me on Twitter at AttachmentGenie, and for people who want to review this presentation again, by this point I should have uploaded my slides to SlideShare.